Hi everyone, this is Kalyan Kumar and welcome to Chemistry Tutorials. We've been doing gaseous state and we just finished part 5 in the previous episode. This is part 6 titled Piston and SPMs. SPM stands for Semi-Permeable Membrane. These are membranes that allow only one type of gas to pass through and do not allow the other gas to pass through. And we are not here in this video to talk about why does an SPM do that, but we are going to talk about what happens when an SPM is used and how do gases diffuse and what is the parameter based on which they diffuse. So let's start with Piston and SPMs part 6 of 13. Now before I begin, let's talk about something very important that I wanted to discuss before we move on to questions, because this episode is full of questions. We won't be doing any theory, so I'm going to explain something to you beforehand. Now imagine that we have a cylinder, and excuse my drawing is really very bad, and okay, suppose we have a cylinder and this is separated by a movable barrier. You can call it a piston or you can call it anything. And imagine there is gas A here and there is gas B here. And the distance, this particular length is X and this particular length is Y. And assume that these values are given to us. Now, if this piston is movable, if this barrier is movable, this barrier will either go up or down in order to balance the pressure on either side. Now, if A and B are initially exerting pressures which are already equal, then it's not going to move. But if one is exerting more, then the piston will move in that direction where the pressure is more and it will expand, and as the volume increases, let's say B has higher pressure, let's say B has 6 atmospheres and A has 4 atmospheres. So this is going to go up till the pressure on both containers becomes equal, because as the volume of this increases, its pressure would decrease. As the volume of this is decreasing, the pressure would increase, and eventually they will balance down. And if let us say this distance moved is A, then the amount by which X increases is A, this particular height, and the amount by which Y decreases is A. So we can make equations based on the pressure and stuff like that, and we'll see that in the questions that we are about to do. So basically, this is going to balance the pressure, and of course we are assuming the piston is massless and there is no friction here. Now, what happens if you have the same cylinder and this were to be a semi-permeable membrane? Let this be an SPM, semi-permeable membrane, and since semi-permeable by its very definition implies it only allows one type of gas to pass through. So let's say it is going to let only B pass through. Now what will happen is, if B goes towards A, now what will it be going to achieve in doing this? Remember, in a semi-permeable membrane, diffusion will happen. Diffusion of B will happen, and it is just going to follow the Graham's law of diffusion. So the logic according to which is that the partial pressure of B in both halves or in both parts should be same. So B goes through the semi-permeable membrane towards A, and there is some B here, and the movement will be such that the partial pressure of B in both containers is same. But since the SPM, now this is what will happen if the SPM is non-movable. If it is non-movable, B will simply diffuse and the pressure of B here and the pressure of B will be equal. But if it is a movable semi-permeable membrane, then what will essentially happen is B will move up and the partial pressure of B in both parts will be same. But if the partial pressure of B is same and the semi-permeable membrane is movable, obviously the pressure on top is going to be higher than the pressure at the bottom, because you also have A here. A is also going to exert pressure. So because of the higher pressure, this semi-permeable membrane is going to move down. Now when it moves down, the partial pressure of B decreases because the volume is increasing on the upper half, and in the lower part, the partial pressure of B is increasing. Again, there's a disbalance of B. So again, B will go from bottom to top. Again, the same thing will happen, and eventually the semi-permeable membrane will be sitting at the bottom and this entire container will be filled with A and B, assuming of course that the semi-permeable membrane does not occupy any considerable volume. So remember, in an SPM, in a movable SPM, you'll also have to ensure that the partial pressure of the diffusing gas is the same. You also have to ensure that the total pressure is also same, otherwise it will not be static. Now let's take a situation wherein we have a container, we have a semi-permeable membrane, SPM. I have gas A and C, I have gas B and C, and let's assume that C is the one that is going to diffuse. Or for that matter, let's assume that this does not even have C, it may be only B. Now the idea is, if this is SPM and only C is allowed to move, let's say, the C is going to move up or down depending upon where its pressure is higher till the pressure of C becomes equal. Now that might disbalance the total pressure, and the piston may move up or down, and eventually the total pressure in both parts should be same. And since the C will stop diffusing only when the partial pressure of C in both halves is same, and the total pressure is also same, it implies pressure of A and pressure of B will also be same when the SPM comes to a stop. So this is how this is going to play out. So we'll take various cases, and this was the basic idea that I wanted to talk to you about before we do questions. So let's start with questions now. So let's remove this. First question coming your way. The figure shows initial condition of a uniform cylinder with frictionless piston of negligible thickness and negligible mass held by a mechanical stopper. So as you can see, this mechanical stopper is holding the piston. Remember, it's a piston, it's not an SPM. So this is only a piston now. Okay. So this is containing hydrogen at 12 atmosphere pressure. This is containing oxygen at 4 atmospheric pressure. Obviously the pressure is more at the bottom, pressure is less on top, which means hydrogen will move, will make the piston move above. That is provided of course the stopper is removed. And this height is given as 50 and this is 50 again. So they are exactly equal. So if the mechanical stopper is opened, calculate the final position of the piston, final pressure in each of the compartments. Now remember, in any question, if by mistake, let's say, suppose this is going to go up, okay? Now by mistake, suppose you assume it is going down, which means you will increase this volume by A, if A is the distance moved, and you will decrease this volume by A. You don't have to worry whether it is moving up or down. Irrespective of what you take, the value of A will be commensurate with what is happening. So if instead of moving down, it is moving up, A will automatically be negative. So that you don't have to worry about. Now, what do? How do we solve this question? They say that this is removed, this is allowed to move, and obviously the pressure below is higher. So this will move up by a distance, let's say A. P1 V1 is P2 V2. Now try and understand this. This is P1 V1 of hydrogen initially and finally, and again this holds good for both hydrogen and oxygen. So because the number of mole of hydrogen in this container will remain constant whether it moves up or down. Now volume is length into cross-sectional area, and cross-sectional area in both parts is same. It's a uniform cylinder. So ultimately it is based on length only. So P1 L1 is equal to P2 L2. So 12 into 50 is the final pressure of hydrogen here into 50 plus X, because it is going to move up. So we have two variables, X and P2. But remember, we can make similar equation for oxygen also. 4 into 50, and since this is decreasing by X, P2 into 50 minus X, and the reason I am taking the same pressure is because this will only come to rest when the pressure on both parts is same. So we have two equations and two variables, we will be able to get their values. X is 25 meters and the final pressure is 8 atmospheres. So let's do one more. The figure shows initial condition of a uniform cylinder with frictionless piston of negligible thickness and negligible mass held by a mechanical stopper. This is going to be a constant thing in almost all the questions. Now here we have 3 compartments. Helium 10, argon 30/7 and neon 5/2. And the lengths, let's see what the lengths are. This fellow is 25, this guy is 35, this fellow is 40. Okay. Now what you also need to understand is not only is the mole of neon, argon and helium remaining constant in their individual parts, the total mole also remains constant, because whatever is the mole of neon, argon, helium, that is the total number of mole, and that total number of mole will remain constant irrespective of where the piston moves. So let this be A, this be B. This is piston A and piston B. If the mechanical stopper is opened, calculate the final position of piston A, that means where does it move. Calculate the final position of piston B, final pressure in each of the compartments, which will of course be same. So I'm going to start off with P final into V final is sigma Pi Vi. That's pretty simple, because remember PV equals nRT, right? So if I were to take the total pressure, total volume, that will be equal to total number of mole into RT, which will be equal to P1 V1 of this part. It will be equal to P1 V1 of this part, P2 V2 of this part, P3 V3 of this part, because P1 V1 will be N1 RT, P2 V2 will be N2 RT, and P3 V3 will be N3 RT, and when you add all of them, you will get N1 plus N2 plus N3 RT, which is what P final and into V final will be. It will be total number of mole into RT. So P final into 40 plus 35 plus 25. Now this was the initial situation, remember. Okay? And the final situation, this was the situation before anything moves. And remember, the total number of mole will remain constant here. Okay? So P final is the final pressure throughout the container. That means whatever is the pressure throughout the container, that will be the pressure in individual compartments too. So P from here comes out to be 5 atmospheres. So if I were to look for helium, 10 into 25 is P1 V1, and the final situation, the pressure is 5, because remember it will be 5 throughout the container, which means it will be 5 here, it will be 5 here, it will be 5 here. So 5 into 25 plus X, I'm assuming it's going up, because remember this is 10 and that is 30/7, which will be 4 point something, and this is 2.5, so obviously this is going to move up. Now from here the X comes out to be 25 meters, which means this A has moved up by 25 meters. For container 2, it is 30/7 into 35, that is the initial condition. Final condition, remember the pressure is 5. And this value will be 35 minus X, because this has gone up. And if this were to go up again, and let that value be Y, then the volume, then the length will increase by Y, so it is plus Y. And remember, if you make any mistake in any of these, the values will come out to be appropriately correct. So if it is going to be moving down instead of up, it's going to be negative. And remember, X we already got. So from here, Y is 20 meters. So we are right, it is going to go up, because remember this is 4 point something, this is 2.5, this is going to go up. And this is the situation. The final pressure is what is asked, and the position of the piston in the two halves is asked. So next one, gases are filled in a container as shown in the diagram. Now this is where you're going to get First question of SPM. Calculate the mole of H2 in the first compartment. Assume that SPM allows only H2 and is movable. So 4H2 and 5N2, and this is 5O2. It's pretty simple. The H2 is going to go up. Partial pressure of H2 will be same. And eventually when this comes to rest, the final pressure here and the final pressure here will be same, or you can say the partial pressure of O2 and N2 will be same. So this is what you get. This is 10, this is 40. Solution, let A be the mole of H2 transferred to the upper compartment, and let X be the distance moved by the SPM towards the upper compartment. And during the diffusion of a gas through an SPM, the diffusion takes place till the partial pressure of the diffusing gas is same on both sides. So pH2 lower, pH2 upper will be equal. So if you were to only balance this, it will be 4 minus A upon 10 minus X. This is 4 minus A by V, ART by V prime, which is the volume here. And since this is going to go up, it is 10 plus X. And since A is the mole of hydrogen effectively diffused here, it will be A upon 40 minus X. So we have one equation involving A and X. And the second equation you can use either for N2, or you can use N2 and O2, or you can use for the total. So P total lower is equal to P total upper. And total mole here are 9. A has decreased because H2 has gone up. So it will be 9 minus A upon 10 plus X, 5 plus A upon 40 minus X. Two equations, two variables. We solve for A and X, and we get A to be 2 mole, and therefore the hydrogen in the first compartment is only 2 mole. A container of uniform cross section as shown in the diagram consists of 3 compartments. Initially piston and SPM are held at a given position. So this is going to be a little complicated, because you got one piston and one SPM, and of course both will be movable eventually. If piston and SPM are allowed to move freely, then find the position of the piston. SPM allows only H2 to diffuse. Now, as I've always mentioned in all my videos before, I have not mentioned this one, but I'm assuming that you will be able to follow those things, is that whenever I give you a question, pause the video, try to do it on your own. Remember, this is for you. You have to think and you have to do it on your own. And it's only when you have attempted sufficiently long enough. It's not going to be a single attempt. It's not going to just happen right while watching the video. It could take some time. Take as much time as you want, because remember, this video will only help you when you do the work. It is not to be watched. It has to be done. You have to do, you have to write, you have to draw the figure, you have to do all the solutions on your own. It's only when you can't have the solution, you're not able to get it, that you look at the video again. So if piston and SPM are allowed to move, you have to figure out, find the position of the piston. SPM only allows hydrogen. So the distances are given to us, and this is 100, this is 200, and this is 100 again. Solution: the final pressure in all containers will be equal, that we know, because both are movable. So 100 plus X upon 9, we are looking at argon. 100 plus X upon 9 will be equal to 200 minus X. I'm assuming it is going up. See, we don't really know what the pressures are. So we are randomly saying it's going up, and this is going up. This is again going, let's say, down perhaps, because that's what the Y means. So 200 minus X plus Y upon the total mole, which is 2 plus 10 minus A. Try and understand what we are trying to do here. So what is V by N equal to? It's RT by P, and P is same in all the containers, and T is also same in all the containers. So what is it that we are doing? We are doing V by N, we are doing equal to RT by P. So V by N in all the containers will be same. So V by N of the first container is equal to V by N of the second container. So we already got X and Y and A. There are 3 variables, so we need 3 equations. And this is for 200 minus X plus Y, that is the volume here. and the hydrogen plus nitrogen total is 10 plus 2, and A has diffused up. So this is the total number of mole, and this is 100 minus Y because this has gone up, and upon 3 plus A. So we got second equation. For H2 gas separately we can do 200 minus X upon 10 minus A and 100 minus Y upon A. So 3 equations, 3 variables. I know it's a little cumbersome to solve, but then you got to solve it. From here A comes out to be 6, X comes out to be 5. Now look at the value of Y. It comes out to be negative 50, which means we assume it is going up, actually it's coming down. So even if you by mistake take a piston to move or an SPM to move up and down wrongly, the value will always adjust itself. So that is the end of this short video on piston and SPMs. I hope you understood what we were talking about. If required, go and watch this video as many times as you want, and make sure you pause the video at appropriate times and make sure that you do all the questions on your own. So with that, we come to the end of this video, and I hope you enjoyed this video, liked this video. If you did, give it a thumbs up. Check out my other videos in this channel. There are some organic chemistry lessons there. There are some more physical chemistry lessons there. I'm going to complete all the lessons that are there in grade 11 and 12. It's going to take some time, but I eventually will complete all of them. And once gaseous state is over, then I'm going to go for inorganic. So I'm going to do organic, physical, inorganic, one by one, as many lessons as I can do as quickly as I can. So in case you like the videos of my channel, please do hit the subscribe button and hit the bell notification so that you can be notified at appropriate time whenever I upload a video. With that, this is Kalyan Kumar signing off. Have a wonderful day. Goodbye, and thank you for watching this.